Welcome to the Deep Dive. Today we're venturing into, well, the endlessly fascinating world of time travel.
It really captures the imagination, doesn't it? In fiction, in science.
Absolutely.
Yeah.
But instead of asking how to travel through time, we're tackling something maybe more fundamental. Why might it be restricted or, even impossible?
Exactly. Forget the blueprints for now. We're looking at the interdictions, as some sources call them.
Interdictions, okay.
Yeah, these barriers, these rules, some imagined in stories, some maybe real, according to physics, that could stop us zipping around the timeline.
We've got quite a range of ideas here. Things from, fictional guidelines to pretty heavy theoretical physics. So if you've ever wondered, why aren't there tourists from the future walking around? Or what rules might time travelers have to follow? Well, you're in the right place for a deep dive.
Should be interesting.
Okay, let's maybe start with fiction. How do stories handle this? Seems like a good place to begin unpacking it.
Yeah, and a perfect example is the Temporal Prime Directive from Star Trek. It's really central there.
Right.
It's compelling because it's an ethical framework. How should you behave if you could travel through time? And what's insightful is how it mirrors that real tension, that desire to fix things versus the risk of messing everything up. Unintended consequences, basically.
Yeah, that makes sense. For anyone maybe less familiar, the Temporal Prime Directive is basically rule number 1. Don't mess with history.
Pretty much.
And the material we looked at, it says it grew out of Starfleet's regular non-interference policy.
Right, the one about not interfering with other developing cultures.
Exactly. So they just took that idea, that ethical core, and applied it to time itself.
And it's interesting how that idea develops in the fiction. Our sources mention that as time travel tech supposedly became more common in the Star Trek world, the need for a rule like this became, obvious. So it gets formalized, I think, by the 29th century.
Yeah, that sounds right. And they set up a Temporal Integrity Commission, like time cops.
Sort of, yeah. To police the timeline, stop people making unauthorized changes, it really shows this fictional growing awareness, this need for responsibility as technology gets more powerful, like a case study.
Serious stuff in the future. But even before it was super formal, our info suggests that, in shows like TNG Enterprise, the idea was already there, a guiding principle, even back in the 24th century. And apparently it's still relevant way later, like in Discovery.
It shows how deep that non-interference idea runs in that universe. It's baked in.
So what are the core principles then?
Well, it's pretty clear. Number 1, prevent interference in past events.
Okay.
2, keep the timeline intact, avoid paradoxes.
Makes sense.
And 3, don't spill the beans about the future. Restrict future knowledge so it doesn't, influence things improperly. It's all about preserving history as it, quote unquote, naturally unfolds.
And they mean it, right? The material says it's inviolable. That's strong.
Very strong.
Apparently, officers can just cite the Temporal Prime Directive to avoid answering questions about time missions.
Convenient, right? But it underscores the potential chaos they imagine time travel could cause.
Definitely.
Our sources also mention the temporal accords. These came before the 31st century.
Okay, what were they?
They allowed studying history via time travel, look, don't touch. Strictly prohibited changing anything.
So learning is okay, changing is not.
Exactly.
Yeah.
Recognizes the value of history, but also the massive risks of trying to rewrite it.
But here's where it gets tricky, maybe. Even with this super strict rule.
Yeah.
The info mentions Captain Picard questioning it.
Yeah.
Wondering if there might be, moral exceptions in really extreme cases.
Yes. That adds a whole layer of complexity, doesn't it?
It really does.
It moves it beyond just a simple hands-off. It makes makes the characters think, too, about the morality of not interfering, especially when terrible things happen.
Yeah, when it's doing nothing the wrong thing, even if it follows the rules. Deep stuff. Okay, so that's the fictional approach. Carefully built rules.
Yeah.
But what about, actual science? Why don't we see time travelers?
Right, and that takes us nicely into the Chronology Protection Conjecture, Stephen Hawking's idea.
Hawking.
Now, this isn't an ethical rule book from the future. It's a hypothesis.
Okay.
It suggests that the laws of physics themselves might stop time travel from happening, fundamentally.
The universe protecting itself.
That's the mind-blowing implication, yeah, that the universe might have a built-in safety mechanism against paradoxes, a kind of self-preservation.
Wow. So physics itself says no time travel. The material mentions Hawking had a funny way of putting it. Something about a chronology protection agency.
He did. He joked it prevents the appearance of closed time-like curves and so makes the universe safe for historians.
I love that.
Ugh.
Cosmic red tape keeping history tidy.
It's a great image. But the core idea is serious. Physics might just inherently prevent paradoxes.
So it challenges those models, like the Tipler cylinder you hear about sometimes.
Exactly. Models like that, which theoretically might allow time travel, often run into problems according to the conjecture.
And the problem is the ingredients. Our info mentions exotic matter with negative energy. Sounds pretty weird.
It is weird, and the conjecture suggests that maybe our current understanding of gravity, general relativity, and this thing called the weak energy condition.
Weak energy condition?
Yeah, it's basically a principle in general relativity saying energy density shouldn't be negative. Exotic matter would violate that.
Ah, I see.
So the conjecture suggests that maybe this exotic matter, this key ingredient for many time machine theories, might just be physically impossible.
So it's not just hard to build. The universe might literally not allow the materials.
That's the idea. It wouldn't just be an engineering challenge. It might violate fundamental physics.
The source material also talks about specific ways this might work physically.
Right. The conjecture suggests that if you tried to create one of these closed time-like curves, the loops in space-time for going back, you might hit, say, infinite energy density.
Yeah.
The machine basically destroys itself right at the critical moment.
Boom. No time travel.
Or wormholes, another popular idea for shortcuts.
Right. Space tunnels?
They might just collapse instantly if you tried to use them in a way that breaks causality, that lets you create a paradox. It's like the universe fights back.
Cosmic fail-safes. That's fascinating. And the notes mention that even theories that do allow some kind of time stuff.
Like the Novikov self-consistency principle, or many worlds.
Yeah, those. Even they seem to agree that paradoxes, the kind we worry about, probably don't happen.
Generally, yes. Novikov's idea is that physics would just sort of conspire to prevent a paradox. If you tried to go back and stop your own birth, something would just happen to stop you succeeding. You couldn't do it.
So you can travel back, but you can't change things in a way that creates a contradiction.
That's the essence of it. And the many worlds or parallel universes idea just sidesteps it.
How so?
By saying any change you make just creates a new timeline, a whole new universe branch. Your original timeline stays untouched. No paradox in the original history.
Okay, that's a neat way around it.
Yeah.
Which brings us to that observation. Where are all the time tourists?
The big question.
Our material raises this. If time travel to the past is possible, shouldn't we, see evidence?
Yeah.
People from the future around?
It seems logical, right? And that lack of obvious visitors is sometimes used as, well, maybe empirical support for Hawking's conjecture.
But it's not proof.
Not at all.
Yeah.
As the info points out, there are plenty of other explanations.
Like?
Maybe travel is only possible to the future. Or maybe only possible back to the point when the first time machine was switched on.
So they can't visit us yet.
Or maybe future societies have really, really strict rules, like the Temporal Prime Directive, but real and effective.
Or maybe they are visiting, but only parallel timelines, the ones we just talked about.
Exactly. So they wouldn't affect our history. Lots of possibilities.
So the empty sidewalks aren't conclusive evidence. It's intriguing, but not proof.
Precisely. And the chronology protection conjecture itself, it's still a conjecture, still theoretical.
Untestable for now.
Pretty much, yeah. Until we get a better handle on things like quantum gravity, a theory that unites general relativity and quantum mechanics. It's in that exciting but fuzzy area of theoretical physics.
Where the big ideas live before we can test them.
You got it.
Okay, so we've got fictional rules, potential physics barriers. What about more philosophical problems, the really head-scratching stuff?
Yes. The logical knots. These get right to the core of what time travel would even mean.
Yeah.
The material highlights the big one. Logical paradoxes. Especially around causality, cause and effect.
Right. Cause always comes before effect. Usually.
Usually. But time travel, especially to the past, seems to threaten that, influencing events after they've happened. That breaks our basic understanding.
And the classic example, everyone knows this one.
Yeah.
The grandfather paradox.
The absolute classic. You go back, you prevent your grandfather from meeting your grandmother.
Right.
So your parent isn't born, so you aren't born. So who went back in time?
Yeah, it just folds in on itself. A complete logical contradiction.
Exactly. It just highlights how altering the past could break logic itself. Makes your head spin, right?
It really does. Like the universe saying, nope, doesn't compute.
Pretty much. The sources also bring up a definition from philosopher David Lewis.
Okay.
He talks about the difference between personal time, how much time the traveler experiences, and external time, how much time passes in the outside world.
Oh, okay. So the time on your watch versus the calendar.
Sort of. If those two durations don't match up for your journey,
Then time travel happened.
according to Lewis, yes. It's crucial for just defining what we even mean by moving through time. It's not just about showing up on a different date.
Right. You could, I guess, experience an hour, but pop out centuries later. Or maybe the other way around.
Potentially, yeah. It shows it's more complex than just moving along a line.
And that links to another point in the material, the challenge of using the word travel for time.
Exactly. Where are you actually going? You're not moving between places in the usual sense. You're moving along the time dimension. Maybe at the same spot in space, maybe somewhere else entirely, but at a different time. What does location even mean then?
It gets really fuzzy. Time is just another dimension, but a really, really weird one with strange rules.
Very strange. Very counterintuitive.
Okay, so let's try to wrap this up a bit. We've looked at fictional rules, like Star Trek's directive, designed to manage the chaos.
To keep history safe, ethically.
Then scientific theories, like Hawking's conjecture, suggesting maybe physics itself forbids it, stops paradoxes cold.
Right. The universe's own rules.
And then these deep philosophical puzzles, causality breaking down, the grandfather paradox, even defining what travel means in this context.
Yeah, it covers a lot of ground. But what connects all of them?
The core worry seems to be paradoxes, right?
Yeah.
And messing up causality, disrupting history.
Exactly. Whether it's Starfleet making rules or physics having inherent blocks, the fundamental concern is the same. Don't break the timeline. Don't create contradictions.
It's amazing, really. Even though time travel is still just theory, maybe even impossible, all these ideas, these interdictions from fiction, physics, philosophy, they're incredible thought experiments.
They really are. They force us to think hard about time, about cause and effect, about how we understand the universe.
Yeah, even if we never build that DeLorean, just thinking about why we can't or why we shouldn't teaches us a lot. It deepens our appreciation for how things work or how we think they work.
Well said. It pushes our understanding, even if the subject itself remains speculative.
So wrapping up this deep dive on time travel interdictions, we've seen these barriers are complex. Ethical rules from imagined futures, possible fundamental laws of physics, and even basic logical problems with the whole idea.
It really spans the gamut, and maybe that's the takeaway. Whether it's ultimately impossible because of science or forbidden for ethical reasons, just wrestling with these limits forces us to expand our thinking about reality itself.
Absolutely. So here's a final thought for you, the listener, to ponder. Which kind of barrier feels more compelling to you? Is it the ethical rules, the Temporal Prime Directive idea made by a society trying to protect history?
Or is it the silent fundamental laws of physics that Hawking proposed? Maybe something unbreakable built into the universe.
Think about it. What would each one mean for how we see reality and our own place in the grand scheme of things? Thanks for joining us on this deep dive.